Okay, so hello, welcome everybody. So our Common Core state standard that is associated with the topics we are going to be covering this week are the number system 7S and S, 2C, apply properties of operations as strategies to multiply and divide rational numbers. So our mission for this week is to learn how to multiply and divide integers. What are integers, you may ask? Well, integers are whole numbers that do not have fraction or decimal parts, and they are positive or negative numbers. There are some examples for negative, -1, -2, -3, and so on, and positive, the ones you know, 1, 2, 3, 4, 5, continuous. So we will be using pronunciation and visualization techniques to help us solve our math problems. Pronunciation is very important because knowing and learning how to pronounce your problems can sometimes have clues and even straight up instructions on how to solve. And visualization puts things in front of you, and it is easier to understand how we get to our answer. So we're going to be using two types, chips and number lines. So we're going to be talking about chips first. So for chips, we're going to be using red chips or red circles to account for negative numbers and yellow chips or yellow circles to account for positive numbers. As I said, pronunciation is key. So for chips, we can replace the times as groups. So it would be draw 5 groups of 3. There you go. Pronouncing it just told you how to solve your problem. So 5 times -3, draw 5 groups of -3. -5 times 3 is a little bit different. Whenever we have a negative in the first number, it is pronounced as the opposite of. So -5 times 3 would be pronounced as the opposite of 5 groups of 3. And for number lines, we are going to be using jumps to replace our x. So 3 times 5, as you can see in the example, is 3 jumps of 5, and this shows you perfectly how to do that there. And 3 times -5, 3 jumps of -5. And remember, whenever we have a negative in our first number of the problem, it is pronounced as the opposite of. So the opposite of 3 jumps of 5. And I'll be showing you how to meet that a little bit later. Okay. So first, our day 1 is multiplication, and we're going to be focused our day 1 is multiplication, and we're going to be focusing on chips. The way we're going to be solving our problems is we're going to pronounce it, we're going to draw them, and then we are going to solve it. So our first problem is 5 times 3. We would pronounce that as 5 groups of 3. Draw 5 groups of 3. So let's draw that. We have 1, 2, 3, 4, and 5 groups of 3 yellow chips. And when we count all of our chips up, we have a total of 15 yellow chips, meaning our answer is positive 15. So our next problem, 5 times -3, we pronounce this as draw 5 groups of -3. 1, 2, 3, 4, and 5. So when we count up all of our red negative chips, we have a total of 15 negative chips, meaning our answer is -15. Our next problem, -2 times -4, which will be a little bit different as I had said. So this would be pronounced as the opposite of 2 groups of 4. So first, we are going to start off by drawing 2 groups of 4. 1, 2. And we have the opposite of. So we're not done yet. We have to draw an arrow showing that we are going to flip the sides of the coin. So we're going to flip from yellow to red to show the opposite. So here's our arrow to show the flip, and we're going to flip 1, 2 groups of -4 this time since we did that flip. And our total, we count up all of our flipped chips, so all of our red chips right now, and that is 8 negative chips, so our answer is -8. For our next problem, -2 times -4, this pronounces the opposite of two groups of -4. So we're going to start off by drawing two groups of -4. 1, 2, and we draw our arrow to show our flip. And we end with two groups of +4. We count our flip chips, 8 yellow chips. Our answer is +8. This is a great representation to show how a negative times a negative equals a positive, because we have to do that flip, which ends us with a positive result. Move on to number lines. We're going to solve these the same way. We're going to say it, we're going to draw it, and then we're going to solve it. So our first problem is 3 times 4. This is pronounced as 3 jumps of 4. We're doing number lines. We have transitioned to number lines. So instead of groups, we're going to be saying jumps. So first we're going to draw our number line. We always start at 0, and I'm going to be using yellow jumps to represent positive jumps to the right, and red jumps to signify negative jumps to the left. So we start at 0, and we're going to jump 3 times the amount of 4. So 0 to 4, 4 to 8, and 8 to 12. Wherever we land is our answer. So we landed on +12. Our answer is +12 or 12. So our next problem is 2 times -5. We pronounce this as 2 jumps of -5. Go ahead and draw your number line. Start at 0, 1 jump of -5, 2 jumps of -5, and we land on -10. -10 is our answer. So again, we have a negative in the first number. -2 times 5. We pronounce this as the opposite of 2 jumps of 5. So again, as always, draw your number line. Start at 0, and first we're going to draw 2 jumps of 5. 1, 2, and we land at 10. But we're not done yet because we have to account for the opposite of the negative in the first number. So we draw an arrow to fly to the other side of the number line. And I went ahead and made that arrow red as we were moving to the opposite side, we're moving to the negative side of the number line. And the opposite of 10 is -10. That is why we fly to the other side. And that is where we finally land. So our answer is -10. For our very last problem, -2 times -5. We pronounce this as the opposite of 2 jumps of -5. So we draw our number line. And at first, we are going to be drawing 2 jumps of -5. So we start at 0 as always. 1, 2. We're not done yet. We have to do the opposite of. The opposite of -10 is +10. So we draw our arrow flying to the other side of the number line, and we finally land on 10, meaning our answer is +10. And this is also another great example to show how a negative times a negative equals a positive. So that is all I have for day 1 multiplication. And now we're going to be moving on to day 2 division. Thank you very much.
Good morning, friends. My name is Miss Michelle, and for today's lesson, we're going to get a better understanding on dividing integers. Before we start today's lesson, let's take a moment to think about what we already know, which is adding, subtracting, and multiplying integers, including all positive whole numbers and all whole negative numbers. Positive or negative, the numbers could change themselves. Dividing integers work in a very similar way to multiplying integers. The number part is usually straightforward. What really matters is understanding the sign. When we divide numbers with the same sign, when either both are positive or both negative, the result is positive. When we divide numbers with different signs, one positive and one negative, the result is negative. The pattern is consistent and will help us determine the sign quickly before we even solve the problem. Another important thing to think about is what division really means. Division is repeated subtraction, or another way of asking how many groups of this number fit into another. When we bring negatives into the picture, it forces us to think carefully about the direction on the number line. For example, dividing a negative by a positive asks how many positive groups fit into a negative number, which is why the result becomes negative. Understanding this will help us understand the rules and make more sense instead of feeling something to memorize. Now that we have a better understanding on how does division work when it comes to integers, let's talk about the chips. The chips usually represent positive when the chips are yellow. The negative chips usually represent the color red. The zero pairs usually cancel each other out. What does division work? Division really means how many groups can we make? With integers, the signs matter. Chips help students visualize the grouping. Now let's do some practice together. Example number 1. Let's solve 12 divided by 3. So we're going to start with 12 positive chips and make three equal groups. So that means each group would get 4 chips. So the answer would be 4. Example number 2. Let's solve negative 12 divided by 3. So we're going to start with negative 12 chips, which means the red chips, and we're going to make 3 groups. Each group would get negative 4 chips, which are the red color ones. So the answer would be negative 4. Example number 3. Let's solve negative 12 divided by negative 3. We're going to use 12 negative chips, which are the red color ones. We need negative groups, so we need negative chips. Each group has 4 negative chips, so the answer would be 4.
For the activity, it's going to be an escape room challenge. You stop by the principal's office to check on an item that you lost. You go into the office and you hear a click. The door locks behind you. A note appears on the desk. To escape, you must use your math skills to solve these problems, using integer chips and number lines to solve the puzzles. Click on the link, or else this message will self-destruct due to our zero tolerance policy. Welcome to today's lesson. Today's lesson is the escape room. Somehow you have found yourself locked in the principal's office, but don't worry, it's all part of the game. To escape before lunch bell rings, you will need to use your knowledge, teamwork, and problem-solving skills throughout this room. You will find riddles, questions, and questions related to solving math problems, while using integers and maybe a few secrets. Each solved challenge will bring you closer to freedom. Are you ready to test your wits and escape the principal's office? Let the games begin. You will work together in groups of 4, and together you will solve the puzzles and find the next clue. Each solved puzzle will lead you to another clue, bringing them closer to solving the final escape code. The first team to solve all the puzzles and find the final code escapes the principal's office. Can your team escape? Let the adventures begin. Our first puzzle. 4 students each forgot their homework, and the principal subtracts 6 points for every missing assignment. So we are going to use this problem by solving it with a number line. We are going to start at 0 and count 4 times by 6. So we're going to start at -6, and we're going to add 6 more to 6, and that takes us to -12. And next, that is 6 more is -18. And adding 6 more to 18 gets us to -24. And I'm just going to stop right there because I know that I only needed to go 4 times. But to check my work, I'm going to count 4 jumps. So 1, 2, 3, 4. And that lands us on -24. So you will answer -24 in your answer box. You must answer this correctly in order to move on to the next clue.